Film number 4 in this series on the TCP/IP protocol stack is about subnets. And subnets is when we separate our network into different address groups or device groups. So you can, for example, say that you have one group for the marketing department, one for the economics department, one for the management, one for the production department, and so on. And the idea is that you create segments with fewer devices or fewer nodes. And it has nothing to do with the physical arrangement of the devices, but it's the logical. So it's about addressing. We separate the different subnets with addresses in a way that will be explained later, and it's used to increase the efficiency. That if you say if you have a very large company with 200,000 devices, you want to create subdivisions in order to reduce the amount of traffic. And also in such networks you have something called a broadcast. So broadcasts are messages that goes to everyone. For example, each time a new computer connects to the network, and that happens every morning when you walk through the doors of HVL. So when your computer or cell phone connects to the network, it will broadcast and see if it how it can connect to the network, and which network is this, and so on. And the routers, they act as the subnet barriers. So the routers here, they say which network is this and which network is there, and operate basically like a bridge, but of course on level 3 in the OC model. So it decides if a message has to go through here and over to the other side, or if it should be on this side only. So the benefits, it's a better way to organize your resources and secure your resources and speed up the network. Those are the 3 main purposes. So if you have a full IP address, the IP address is in version 4, it's 32 bits. So a number of bits is for the so-called routing prefix. And the routing prefix tells you where the network is. So for example, this blue section here, the network prefix could be for the company, and then the red one for the subnet within the company. And the routing prefix is both the network prefix and the subnet number. So all the bits here, that part of the address tells which routing prefix it is. And the rest here is for the host numbers. So in other words, you have a number of bits to tell you where it is, and the rest is who it is within that subnet, within that part. So let's say that we have a company. Let's say, for example, Google as a company. Google company would be blue. The subnet, for example, sales department, would be red. And all the different computers within the sales department would be the yellow section here. So it's a compact representation of an IP address, which is the classless interdomain routing, replacing A, B, and C. So the division line here between the different networks or the routing prefix and the different hosts would, with class ABC, be confirmed to 8-bit hosts or 16-bit host or 24-bit host. So you only had those 3 groups, but now you don't have to specify how many bits you use for this or how many bits you use for that. You have to specify it, but not within those strict sizes. And the notation is like this. If you have a network which is a 24 network, you specify it like this. You say the very first address in your group of addresses. So it's, for example, 192.168.100.0. That is the very first address in your group. And then 24. 24 meaning that you have 24 bits for the routing prefix, and the rest, which is 8, is for the different hosts. So how many hosts can you have with a 24 /24 address? Well, it's 32 address all in all, minus 24 because that was used for the routing prefix. So you're left with 8, so 2 to the power of 8, 256. So you have 256 addresses in this yellow section. However, 2 are reserved. 1 is for the network as a whole, so this network here with all the yellow numbers. 1 address is to access the network as a whole, and 1 address is reserved for broadcast. So whenever someone inside wants to broadcast to all the others something, they use a specific address. So among the 256, 2 are occupied, 1 for the network as a whole and 1 for broadcast. So you are left with 254 different hosts at the maximum inside this network. Let's do another example. 10.12.24.0, that's the very first address, and /22. /22 means that you have 22 bits for the routing prefix, leaving 10 bits for hosts. 2 to the power of 10 is 1024, minus the network itself and the broadcast. So you are left with 1022 actually. The network itself is the very first address, the broadcast is the very last address in the entire group of addresses.